This class we worked out three problems. First problem is a parallel resonance circuit is required to have resonant frequency is equal to 2 megahertz. Impedance at resonance is equal to 50 kilo ohms. Quality factor Q0 is equal to 100. The question is determine the values of resistance, inductance and capacitance. At resonance, impedance is equal to resistance, that is equal to 50 into 10 power 3 ohms. Quality factor is equal to omega naught into R into C. Omega naught is equal to 2 into 10 power 6 into 2 pi, that is equal to 12.57 into 10 power 6 radians per second. Quality factor Q is given 100. 100 is equal to 12.57 into 10 power 6 into R. R value is 50 into 10 power 3 into C. I can calculate C. C is equal to 159 picofarads. Omega naught is equal to 1 by root LC. Omega naught square is equal to 1 by LC. L is equal to 1 by omega naught square into C. I can calculate L. I know the value of C and omega naught. L is equal to 39.8 microhenries. I can check whether the problem is right or wrong. Omega naught is equal to 1 by root LC. That is equal to 2 megahertz or 12.57 into 10 power 6 radians per second. The same answer I will get. Second problem is, this is a parallel resonance circuit. Resistance value is 1 kilo ohms. Inductor is 15 millihenries. Capacity is 50 microfarads. Determine resonant frequency, quality factor and bandwidth. Omega naught is equal to 1 by root L into C. Substitute L and C in this equation. Omega naught is equal to 1154.73 radians per second. So 2 pi F is equal to 1154.73 radians per second. I know that I can calculate frequency. F is equal to 1154.73 divided by 2 pi, that is equal to 183.78 hertz. Quality factor Q0 is equal to omega naught into R into C. Omega naught is 1154.73. R is 1 into 10 power 3. C is 50 into 10 power minus 6. Q0 is equal to 57.74. Next I calculate bandwidth. Bandwidth is equal to omega naught by Q0. Omega naught is equal to 1154.73. Q0 is equal to 57.74. Bandwidth is equal to 20 radians per second. Or bandwidth is equal to 1 by RC in the parallel resonance circuit. 1 by 1 into 10 power 3 into 50 into 10 power minus 6. That is equal to 20 radians per second. Third problem is, an impedance coil having an inductance of 0.03 henries and a resistance of 4 ohms is placed in parallel with the variable capacitor. The circuit is connected to a 220 volt 50 hertz supply. For what value of capacitor will the line current be minimum, and what are the values of branch currents, total power and quality factor? The current will be minimum when it resonates at 50 hertz. I can calculate XL. XL is equal to 2 pi FL. XL is equal to 9.42 ohms. At resonance, Z is equal to root of L by C. Z square is equal to L by C. I can calculate C. I know the value of L. L is given 0.03. Z is equal to 9.42 the whole square. That is the Z square value. Therefore, C is equal to 3.38 into 10 power minus 4 farads. Or C is equal to 338 microfarads. Next I can calculate XC. XC is equal to 1 by 2 pi FC. That is equal to 9.42 ohms. IC is equal to V by XC. 220 by 9.42 is equal to 23.35 amps. IZ is equal to V by XL. 220 by 9.42 is equal to 23.35 amps. Current at resonance, I0 is equal to V by dynamic impedance. Dynamic impedance is equal to L by RC. Therefore, I is equal to V by L by RC is equal to V into RC by L. I know all the values, substitute all the values in this equation. Current at resonance is 9.91 amps. Power consumed is V into I, 220 into 9.91, that is equal to 2180.2 watts. Next I will calculate the quality factor. Quality factor in terms of inductance. in parallel circuit, Q naught is equal to R by omega naught into L. Omega naught is equal to 314.16. Q naught is equal to 0.42. Quality factor in terms of capacitance, Q naught is equal to omega naught into R into C. Q naught is equal to 314.16 into 4 into 338 into 10 power 6. Q naught is equal to 0.42. Thanks for listening.